Jai Hind to all. Myself Yogendran Prajapati, Assistant Professor at Akgec Engineering College, Ghaziabad. Dear student, today I am going to teach a very important topic of the graph theory. Graph theory is a main important topic in the discrete mathematics or discrete structure of theory of logic. This graph theory is also included in the another subject just like a data structure, database management system and many more. Graph theory is also a most important topic for the research area. But today I am going to teach with respect to the university examination and GATE examination. Before we start, first we give the very simple definition of the graph, how the graph are designed and what is the some basic terminology of the graph. Now graph can be represented with the help of the V and G, where V is a node or V stand for the also a vertex. For example, this is a simple point is known as the node and the line is known as the edges of the graph. The graph can be in other word we can say that graph is a collection of the vertex and edges, or graph is a simple graph we can also known as the a set of node. For example, V and E, where V is this number of node. For example, 1, 2, 3, 4, that node A, B, C and D. Now, this is the A's. First is that is from A to B. The second is that is known as the A to C. The third is that is B to C. And the fourth node, that is fourth edges, that is known as the C to D. C, where is the C? This one. Now this is known as the graph. Graph where ABCD is a node and A to B, that is known as the vertex. Then we move the different type of the graph. Different type of the graph. Graph are basically two types. First one is a directed graph. In this directed graph, direction of the graph are given. And the second one is the undirected graph. What is the directed graph? That is very simple. Direction of the edges are the given, then that type of the graph is known as the directed graph. If this graph we represent in the term of the relation, then we can say that if node A and node B, then A related to B, but B is not related to A. It means that is A and B, these two nodes are relation with the antisymmetric relation if with this graph are converted into the another form. Now if node this is the C, then B related to C, but C is not related to B. That is the directed graph. The directed graph with the help of set of vertex that are connected with the directed A's are given, but if we move on the very vast area application of this directed graph, then we can say that these 2 points are related. 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 But the relation are given from B to C, but not relation from A to C. That is the meaning of the directed graph. Yes, that is a very important graph, and this all the research work are mostly questions are question asked in this undirected graph. The undirected graph is also the set of the vertex and edges are connected together by the undirected, where the direction of the, for suppose A and B, and A is also related to B and B is also related to A. It means though no relation is given in this graph from any node, then such type of the graph is known as the undirected graph. If this is node C, it means C related to B and B relation to C is also. Similarly, C to A, it means if we explore in the term of the relation, all nodes are symmetrically associated, then such type of the graph is known as the undirected graph. And in directed graph, all nodes are associated with the anti-symmetric relations or anti-symmetrical way. That type of the graph is directed graph. And here is a symmetrical way, A relation to B, B relation to A are connected to B, B are connected to A. We can say that that is the undirected graph. Now some move on the some another example of the graph, that is known as the null graph. Null graph, node are given, no edges are the given in the graph, then that type of the graph is also known as the null graph. The graph is known as the null graph if contain no edges, no edges are the contain, then we can say that that type of the graph is known as the null graph. If we explore in the term of the how the different type of the noded are associated, it means A is not associated to C and A is also not associated to B. Only one relation are formed, that is known as the reflection relation. It means A it also itself relation, C is also itself self relation, then such type of the graph is known as the null graph. Only reflection of the node are given, then that graph is known as the null graph. Another here is not mentioned, that is known as the trivial graph. That is also very important. A single node is also known as the trivial graph. Single node. Okay, that is very simple definition of the trivial graph. Now simple graph. This is another example of the graph, that is the simple graph. What is the simple graph? A graph is known as a simple graph if it is not connected to any type of the loop or a multi-edges, then the simple graph must be undirected graph. Here is a all undirected graph is known as the simple graph. And here is one point is written that there is no kind of the loop. It means this one. It is understood because every node are itself is relation, but here is this point are not mentioned. We can say that this type of the graph is known as the simple graph. And the simple graph described as follows: A, B, C, D, that is the 3 node simple graph. Now that is the 2 node simple graph. Now here is a 4 node simple graph. Here is a 4 node simple graph. So 2 node, 3 node, 4 node, 5 node, we can draw any combination of the node. Now this is another example, but this graph cannot be implemented. When we are going to implement this graph, that is very easy to code this graph, but there is a very tough to code this graph. That is also known. Theoretically it is possible, but practical this graph is not possible. A graph is known as a multi-graph. This same set of the vertices contain a multi edges in this type of the graph. It means from these two nodes are relation in two different one, this one and this one, and it means that is the undeterministic type of the relation between the two nodes, and undeterministic pattern are not implemented. The relation between these two nodes is a two type. This is also known as the multigraph. It means n type of the relation between the two nodes is known as the multigraph. Only single relation between the two nodes is known as the not a multigraph. Here is a not a multigraph, but here is the multigraph. We move on another important type of the graph, that is known as the complete graph. That is very simple definition of the complete graph, and that is very easy to understand. The complete graph is known as the, if the graph is pair of the vertex are connected with exactly once, it means every node are connected to every node. That is very simple definition. That type of the graph is known as the complete graph. Now, here is a 3 node complete graph. We can also draw the 4 node complete graph, 5 node complete graph, and this is the formula by which we can compute the number of the edges in a complete graph. Now, what is the 4 node? 1, 2, what is the definition? All nodes are connected to all node, then that type of the graph is known as the complete graph. It means that is node A, B, C and D. It means this node A are interconnected to B, C, D. Node B are interconnected to C, B and A. So, node C are interconnected to all the node. Now, this is the K4, K for the complete, 4 is a 4 number of node complete graph. Now, we can move on the another example, that is K5 complete node, complete graph. That is what is the, now this is the node 1, node 2, node 3, node 4, node 5, A, B, C, D and E. This is the simple graph. Now, every node are interconnected to every node. It means node C are interconnected to node A. Now, node E and now this is node as the node C. So, now node E are interconnected to all node. It means this connection and this relation are formed. Same process we follow for the all node. Node D are interconnected, now this one, now this one. Now node C are interconnected to this one. Now node A, now this is the K5 complete graph. And what is the number of the noded is in this complete graph? Simply 5 and 5 minus 1 divided by 2. That is the number of A's in the complete graph. Now that is the 5 into 4 divided by 2. It means total 10 number of edges are in this complete graph. That is very simple way. It means in K4 complete graph, 4 into 3 divided by 2, it means total 6 edges. Here is a 10 edges. That is very simple calculation. The number of edges in a complete graph, if number of node is n, then n into n minus 1 divided by 2. I think that is the better understanding for the node. One basic terminology here we are going to discuss, that is the degree of the node. That is very simple one. What is the degree? The number of edges on a node is known as the degree of the node. Here 1, 2, 3, 4, 5, then the degree of A is 5. What is the degree of C? we count the number of noded on this node, then that is known as the degree of this graph. Now 1, 2, 3, 4, 5, again the degree of C is equal to 5. And what is the degree of D? Degree of D again 5, and the degree of E is also 5, and the degree of B is also 5. That is here, there is a, here what is the degree of C? 2, here degree of this 2, and the degree of this 2 is also a 2. Yes. What is the degree of the complete node? Complete graph. The degree of the complete graph is equal of all nodes. Here 5, 5, 5, 5, here 2, 2, 2, and we are taking another node. Now the degree of this one is 3. The degree of the complete node is 3, and all the nodes are equal degree. Now we move another graph that is known as the regular graph. What is the regular graph? That is a very also the simple definition of the regular graph. If the degree of the all nodes are same, then that graph is known as the regular graph. For example, this one graph is known as the regular graph because the degree of all nodes are same, that is 2. The degree of the all nodes are same, then that graph is known as the regular graph. For example, this graph is also known as the regular graph because the degree of all nodes is 2. All complete graph is regular graph because in complete graph the degree of all nodes are equal, but all regular graph are not complete graph. That is a very important concept. Now we move on the another concept of the graph, that is known as the planar graph. Planar graph, a graph can be drawn on a plane is known as the planar graph. But the one important concept are written, a graph do not cross, any edges do not cross, then that graph is known as the planar graph. Now this is one is the planar graph. Now if we taking this example, node A, B, C, D, this is not a planar graph because these two edges are crossed to each other, but we can draw this graph into a plane without crossing any type of the edges. For example, now this one A, B, C, D, or now we cannot draw here, we can draw here. This graph and this graph are same, but in this graph any edges are not crossing to each other, so that this graph is also known as the planar graph. This one is a planar graph, this one is a, that is known as a K4 planar graph. Now this is another example of best example of the bipartite graph. Bipartite graph, the definition are written here, but we taking the very simple way. A graph, bipartite means the node of the graph can be divided into the two parts, V1 and V2 sets. The node of the graph are partitioned into the two parts, part 1 and part 2, in such a way the start is live from this set, and the end point of that is live from the second set. If such kind of the partition in a graph, then that graph is known as the bipartite graph. Now here, how many total number of edges? V1, V2, V3, V4 and total 9. 9 edges are partitioned into the two set in such a way that the start point of is live from the set 1 and the end point of the is live from the set 2. Then such type of the graph is known as the bipartite graph. Now here is a complete bipartite graph. Now that is very simple, K3 and K4. Here is 1, 2, 3, 4, 1, 2, 3. Each are connected to each node from this point. Each node are interconnected to each node. Each node are interconnected to each node. Then that type of the graph, this graph and this graph are simple. Here is very complicated, but here is a easy one. So this graph is known as the complete bipartite graph, and the same logic we are applying in this graph, that the node of the every graph node are degree of the every node are same. Now the very important topic, Euler graph and Euler circuit, Hamiltonian graph and Hamiltonian circuit, we discuss in the next lecture.